Hello, everybody. Video number 2, periodic table. Let's do the vocabulary for this unit so you can get onto that quiz. I don't know how many of us didn't do the quiz from last unit yet because I'm still in that unit, but y'all got to get through this quiz a little bit faster, okay? Fill this piece in. Remember, in your learning target for this lesson, I can define the specialized vocabulary of the periodic table unit. Vocabulary comes now. Bam. Ionization energy. Oh, this is a graph of the periodic table and the ionization energies. You can see that the one in the top right-hand corner has the highest ionization energy. Okay. This, by definition, is the energy needed to remove the first valence electron. So this is the energy needed by a different atom to take my electron or to take my valence electron, and that's my ionization energy. Okay. To make me an ion, how much energy does the atom next to me have to put in to get my electron, right? Okay, electronegativity, another graph of those. Notice electronegativity is the highest in the upper right-hand corner. This is the ability of an atom to attract another electron. Specifically, you could say, how thirsty is that atom? If that helps you understand it, but that's not the definition. You can't just write that on the test. I say that to help you understand the ability of an atom to attract another electron. If I have 7 valence electrons, I am mad thirsty for that 8th electron. Okay. If I have 1 valence electron, I'm not real thirsty for electrons. I kind of I'd rather get rid of my 1 than gain 7. Okay. So electronegativity, the ability to attract another electron. Atomic radius is simple. This picture shows us how we actually define it. It's the radius of an atom. They define it by half of the bond length between a diatomic element. Okay, but that's actually never going to be in our curriculum ever again, that particular thing. It is simply the radius of an atom measured by half of the bond length of the diatomic molecule of that element. Okay, you just need to know it's the radius of the atom, which effectively a larger radius, wider atom. It helps us understand the width of the atom or the atom's size. Atomic radius is the atom's size. Okay. Ionic radius, and here's a picture of what happens. Does the ion get bigger or smaller? And here the ions are in red or blue, and the base atoms are in gray. So you see metal ions lose their electrons and their ions become smaller. Non-metals on the right gain electrons and their ions become bigger. Okay. So ionic radius is the radius of this ion. Does it get bigger or smaller in relation to the atom of that element? So does the fluorine I see, for example, what happens when it becomes fluorine minus 1? Well, I gain an electron, it becomes bigger. Easy gain. Chemical reactivity. So this is I missed a picture. Here is a mock periodic table to show you where things are the most reactive. Notice it's in both corners. So I don't know which way is which for you guys. Probably this way because it's opposite of what I would think, right? The top right nonmetal is the most reactive nonmetal. The bottom left metal is the most reactive metal. Okay. Whoa, went too fast. The behavior of an element based on the number of valence electrons and the number of shells. We'll get into that so you can understand effective nuclear charge and electron shielding. Okay. Metallic character. I can talk about who's more metallic and who's less metallic, and this picture shows us the trends. This is the ability of an element to readily lose electrons. Losing electrons, metals are losers. You'll hear me say that a lot. So how easy do I lose an electron? The more easy I lose an electron, the more metallic I am. Luster is a science word for shiny. The shinier I am, the more metallic I am. Can I conduct electricity? And ductile means to draw into wire. And malleable means to pound flat. So these are all the words that we use to describe what a metal is. The more of those I have, the more metallic I am. Non-metallic characters can be the exact opposite. This is how non-metal I am. So this is all to the right-hand side, which is this way for you guys, right? To the right-hand side of the staircase. This is the ability of an atom to attract electrons, because that's what non-metals do. They grab them up. They're dull, they're non-conductive, and they're brittle. These are all the actual properties of non-metals. So we need to be able to differentiate between metal and non-metal. based on those, and that is what the lab should be that I didn't put in the tracker. Got it? Got it. Metals. Here's a picture of some metals that you know. Metals are elements that lose electrons, have luster, conduct electricity, and be ductile and malleable, found on the left-hand side of the staircase. That particular definition and the one for metallic character are very close. So when you start studying for the quiz, can you differentiate between the word and its very, very similar definition? You need to be able to pay attention to that. Maybe you go with shorter word, longer definition. Maybe that's a way to remember. But as you study, you need to pull in pieces there. How do I differentiate between those two things, okay? Because they're close. Metalloids is a mixture. So here's a picture of which ones are metalloids. Remember, they're on the top and bottom of the staircase, not including Al. So these are elements that have a mix of metal and non-metal properties. They are touching the staircase, except for aluminum. Okay? Non-metals, these are the yellow ones. Non-metals, an element that detracts electron, are dull, non-conductive, and brittle, found to the right of the staircase. Notice that is very, very similar to non-metallic character's definition. Please figure out how to differentiate that for yourself so you don't have to take the quiz 30 times. Alkali metals, this is the first group. This is group 1. Of course, not including hydrogen, because hydrogen is not a metal. So group 1 metals, they have one valence electron. Notice hydrogen is not a metal. It's not part of this group. It's above, it's up, it's a gas. It's not really hooked onto the elements aren't touching each other. Okay. Alkaline earth, 2 words, group 2. You're gonna hear me say that a lot. Group 2 metals, they have 2 valence electrons. Nope, 2 words, group 2. Okay, alkaline earth. Moving on, halogens. This is group 17. So this is group 17 elements. They'll have 7 valence electrons. They want one real bad. These guys are the thirsty elements. They're mad thirsty for another electron. Noble gases are just what they sound like. They're noble and a little bit snooty. Group 18, they have their full valence shell. So this makes them very unreactive. He is full with only 2 valence electrons. It doesn't need 8. It can't hold 8. It can only hold 2. But 2 fills it. That first shell, remember, first it goes 2, 8, 8. So 2 is full. So as long as it's full, it's noble because it doesn't want any more. It is the least thirsty of all the elements possible. It don't want no more electrons. So it doesn't react with anybody. Transition metal are the lower block. So you see that the periodic table kind of starts up with these 2 sections that go up higher. And then that low piece is all transition metals, it's called. And they're not predictable. So this is the metals in group 3 through 12. Their properties vary. What you do need to know is, check it out, pretty wavy, they form colored solutions in water. Okay, the solutions have colors. This is how we use a lot of these for fireworks. Periodic law, here's a definition of it. This is the physical and chemical properties of elements become predictable when they're arranged by atomic number. So predictable as in periodic is like a periodical is something that comes weekly or daily. You know when it's coming next. It's coming every once a week or every day that you get the newspaper comes. That's a periodical. Okay. I think we're almost done. Periods. Periods are going across. And there is a piece on the, wait, this is your left-hand side, right? There's a piece on the left-hand side of the periodic table that says the word periods and they're numbered. Okay. This is across the periodic table. Every period has the same number of energy levels. So period 2 has 2 energy levels, and period 3 has 3 energy levels, and it's 3 all the way across, which is cool. Okay. Groups and families go up and down. The yellow, green, light blue, and blue are not real families. We group that all together, by the way, we call it the BCNO group. The red, the orange, the purple, and the pink, those guys are actual families. So as I go down the periodic table, they have similar properties because they have the same number of valence electrons. That same number of valence electrons means that they act similarly chemically. Okay. Diatomic elements, there's 7 of these guys, right? Yeah, 7 of them. Oh, wait. Oh, yeah, that's funny. Special group of elements that are only found in groups of 2 in nature. And remember, I taught you guys Hofbrinkel to remember which ones are which. You got to know which ones are 7 or diatomic. When we start getting into chemical equations, If oxygen is a lone atom in a chemical equation, it will be O2 because it's one of the diatomics, and we'll need to know that when we're counting atoms. Allotropes, this is a good big new word we're going to throw out there. This is same atom, different arrangement. So a substance made of the same elements, but with different physical and chemical properties because of different arrangement of atoms. The example is, the cliched example is graphite and diamond, because they're both made of carbon, but their physical arrangement of the two things make them allotropes. Because their physical arrangement is completely different, their properties are completely different. You went from one of the softest substances on the planet to one of the hardest substances on the planet, and it's made out of the same thing. That's kind of weighty. And well, we're done. So study up, take your quiz, make sure you check on those ones that have similar definitions with similar vocab words, and figure out a way to differentiate them so you don't miss those four. Okay? That's it.